So let's see. You are on calculate the probability that Maxine knocks over at least 2 Skittles in less than 3 of the games she plays. Okay. So what are we given? This is where it gets tricky. So like, this is how many trials are there? That's different. And the number of trials is 6. There's 6 trials, yes? But we're looking at the probability of knocking over at least 2 Skittles in less than 3 of the game. Okay, 2 Skittles in less than at least. Skittles in 3 games.
He plays 3 matches every day. Somewhat.
So this sounds to me like a given kind of situation, right? So similar things. We're looking for binomial, we need a fixed number of trials, which we have. For a binomial, we also need to know it's independent, which they give you as a hint. So they're independent from each other. Then there are 2 outcomes. This is the problem. We have to change this into, see it as a 2 outcome scenario, success or failure. Okay? That's the big conceptual problem here. Before this point, we've just been doing like 1, 2, 3, 4. In this case, success is if we get at least 2, so 2 or 3, right? 2 or 3 is success. Another way to say that x is greater than or equal to 2. And then a failure would be anything else. 1, 0, 0, or 1. So x is less than or equal to 1. Yes? These are the success criteria, so this is going to be P and then failure. Okay? So we're going to split that into success, failure. And we need to figure out this probability. We can use the table. So what's the probability of x equals 2 and then the probability of x equals 3? It was 4 over 30, and what's P, the probability of getting 3?
1 over 30.
1.
1 over 30.
Yes. We added them, so we have a 5 over 30, which is a 1/6. That's fixed. So now instead of it being that other thing, right? Now we're seeing it, our binomial distribution means that this is a success if we get 2 or 3. This is independent and it's every time. So now we have our p-value equals 1/6. N is 6. And then we need to figure in the less than 3 things. What's up here? Ah. So we have enough. Sorry. Okay. So we now have our binomial, like you can graph this, right? The binomial is 6 trials at a 1.6 rate. That means that the number of times that it will be either a 2 or a 3, successes.
Binomial.
Okay, that's gonna make a graph. This graph, based on this number, 0.5 is in the middle. This graph is gonna look like this. Something, I'm guessing. It's not gonna look exactly like that. Your dad don't come back at me. But we have 0, 1, 2, 3, 4, 5, 6 trials. Yes? So they want to know, this is the last part, at least 2 Skittles in less than 3 games. So this is the part we now care about. Less than 3, does that include 3? No, does not. It's this. We care about this one, and this one. We need these, this. So on your graph, you're gonna put in the probability of binomial, binom, C, D, F, 6, 1, 6. And then you're gonna go 1, 2, up to 2. Okay. In less than 3 games, what's the probability of us getting at least 2 Skittles? Why are you bowing at me? Do you forget who I am? Bowing at me is a short way to freak me out. Okay, so for in terms of big concepts, yes, this seems like a really difficult problem. It is a very difficult problem. So then you have to identify the number of trials, right? And then you have to see it as 2 outcomes, success and failure, right? You identify the successes and you use that table to make one fixed probability. And if we add this up, which we've been practicing, the probability on any roll that you get a 2 or a 3 is 1/6, right? So then we're taking that as our probability for success. Success would be rolling a 2 or a 3. So then that's our new probability of success. Then we have to figure out what is that part in less than 3 games, right? If we wrote out, this is where our practice comes out. This is in 6 trials.
What?
There is a 1.6 probability of success. For 0, 1, or 2 trials are successful. Okay? So what we're saying is, in a total number of 6 trials, what's the probability of us getting at least, or at most 2? 0, 1, or 2. Remember, because we go from the left, right? If it was the other one, we'd have the other problems. 2. And then the probability of success for just rolling that one thing is 1/6. Then you should get the correct answer. Okay, bing bongs, let's do break. We're gonna do a 10-minute break. Oh my God. I have to go find a Coke or something. Am I dying? Food coma is crazy.